All right, question 31 through 35. So we're getting to the part that most of you, these were the questions that you remembered the most after the Regents exam. So question 31 through 35 is about mining and the use of lithium. So it says lithium is a highly reactive alkali metal that is used in the manufacturing of lubricants, pharmaceuticals, glass, and rechargeable batteries. The demand for lithium has grown because lithium is often used in modern electronics like phones, laptops, and electric cars. When in operation, a battery electric vehicle produces zero tailpipe emissions. Okay, so remember when we talked about like climate and things like that, we talked about how cars producing CO2 is one of the things that is of concern, and how as a society or as a population, one of our goals is to kind of reduce the amount of carbon emissions that are happening. The infographic below summarizes the average amount of emissions measured in tons of carbon dioxide associated with the manufacturing and use of 3 different types of vehicles during their lifetime. So I'm going to highlight this because that's a kind of a crazy looking unit there, and I'm going to just make sure I remember that that's what that stands for, is tons of carbon dioxide. Okay, so we have life cycle emissions associated with production of use of different types of vehicles. So we have the battery electric vehicle. I'm going to highlight that in blue, and tells us each step. So battery manufacturing, vehicle manufacturing, fuel efficiency. Overall, it is a total emissions of 41 tons of carbon dioxide. So remember, they talked about tailpipe emissions being 0, but we also want to consider that this is overall, even in manufacturing, what is the total that has been released. Okay, so we're considering both pieces, both the manufacturing of the vehicle and how much it is emitting as you drive it or use it. Okay. Then we had our hybrid electric. So this can use both gas and electric. And then we have our internal combustion engine, and that has a total of 57 tons of carbon dioxide. Okay. All right. So question 31 says identify the type of vehicle. So type of vehicle. So I'm going to tell you that some people lost points here because they were not careful in terms of what type of vehicle they chose. Okay, so there was 3 different types of vehicles, and your answer should have specifically been one of the options given. So either battery electric, hybrid electric, or internal combustion. From the infographic that has the smallest negative impact on the environment. Okay, so I want you to think about what would the negative impact be here. So the negative impact would be the production of carbon dioxide. So if I'm talking negative, I want to have a negative would be producing the CO2, right? So if I want the smallest negative impact, I want to produce the least amount of total carbon dioxide. And so if I look at my picture, I know that my blue number here, this 41, is the smallest for total emissions compared to the green and the orange. Okay, so if I look, my blue vehicle was the battery electric vehicle. Now, a lot of people put electric vehicle, and they did not clarify whether it was the battery or the hybrid. So you had to clarify it was the battery electric vehicle that would have given the least amount of evidence. So I'm actually going to just switch over here so that I can type without using that pen, because that was getting a little bit difficult. And I'm going to use a text box, and then we'll kind of switch back. So my answer should have been battery electric vehicle. Okay, and then I had to give evidence. So justify my answer, providing evidence from the infographic. So evidence is just basically like, why am I saying this? So my answer here is kind of like a claim. So I'm claiming that the battery electric vehicle had the least amount of emissions. My evidence is why did I choose that? So the reason I chose battery electric is because 41 was the smallest value, right? So my evidence would be the battery electric vehicle produced, or we could say had the lowest total CO2 emissions, right? That's it, something simple. So basically when they're looking for evidence, I want you to look for evidence directly from that model. So why did I choose that type of vehicle? The model told me it was the least carbon dioxide emissions in production and use. Okay, so keeping in mind that our goal is to kind of have lower carbon emissions over time. That's kind of a desire of society or something that society as a whole wants to do. We're going to read our next piece of information. So they're giving us a little bit more information here for our next question. So it says the data table below summarizes originally proposed toll rates for motorists entering New York City by Port Authority bridges and tunnels from New Jersey. Vehicles eligible for the Green Pass discount include plug-in hybrid electric vehicles and battery electric vehicles. Okay, so we have they're giving a discount to vehicles that are hybrid electric and battery electric. So if I think back to the question we just answered, the model that we looked at, the infographic, I'm going to guess that that's probably because we want people to drive those vehicles that produce less carbon dioxide. So it says bridge and tunnel tolls for motorists entering New York City from New Jersey. We have class 1 vehicles with 2 axles and single rear wheels. They had a toll off-peak hour of $12.75, a toll peak hour of $14.75. And if I look at this data for a pattern, I'm seeing that overall my off-peak hour is cheaper than my peak hours. Okay. And as I got to more axles, I had a higher toll, right? And I'm paying for each additional axle after that. And then my Green Pass was cheaper over time anyways. So if I had a Green Pass vehicle, which was a vehicle that had lower carbon emissions, I could pay $9.25 instead of $12.75. So it says vehicles entering New York City add pollutants to the air in a congested urban area. Describe the economic benefit. So economic benefit, that's an important word here. So economic benefit, economic means money, right? So we're talking about the financial benefit of this. To motorists who drive class 1 and class 7 vehicles during off-peak hours that qualify for the Green Pass toll rate. So our Green Pass toll rate is here. So we want to know what the economic advantage is. So the money advantage of driving during off-peak hours. So why is this in green better than this in blue? What is the economic advantage? Okay, so my economic advantage is that if I drive during an off-peak hour, I have to pay less money, right? So my answer for that would be driving during off-peak hours is cheaper and you will save money on the toll. Okay, so that's my economic benefit. Benefit means something positive, right? And I want to save money. That's a good thing for me. And then the second part is we have to discuss how the wants and needs of society are affected by the Port Authority toll plan. So how does this toll plan as a whole affect the wants and needs of society, right? So one of the things we talked about in our last question is that the want of society is to limit air pollution, to limit the amount of carbon dioxide that is being released. And so by charging less money for a car that emits less CO2 or just lower air pollution, I'm addressing a want and need of society. So a want that I want to produce less emissions. Okay. So I might write something like, since a green or a low emission vehicle, vehicle is cheaper, more people will drive low emission vehicles, which will lower the amount of air pollution, right? Or you could have said the amount of carbon dioxide that is produced. Okay, so it's just the idea that like I'm basically trying to give people a benefit for driving something that produces less pollution, and especially driving during, even if you drive during off-peak hours, that's also something that will help. Okay, our next question says lithium is currently sourced from surface mines or underground brine reservoirs. Lithium ore extracted from open pit mines is dried in fossil fuel burning kilns. The underground reservoir brine method uses evaporating ponds and solar energy to collect lithium from brine water having a high concentration of various salts. The table below shows some information relating to these two mining methods. So remember, it is not unusual on this exam for you to be reading about things you might not be familiar with. So if you read something and you automatically, you're like, I have no idea what a mine is or a reservoir brining, I don't know how they mine lithium, that's okay, right? They're giving you information that you need. So they told you how we get lithium, so either from mines or underground brine reservoirs. And they told you that if I'm mining it, it's dried in a burning kiln. If I'm using a brine method, I am evaporating salty water to collect the salts that are left behind. Okay, so they're giving you what you need to know in terms of how those two things work differently. So then they told us that if I am going to be mining, they have emission of carbon dioxide and the use of water and the use of land. So kind of what is involved in each of these methods. So they're showing a comparison of mining versus using the reservoir brine method. So it says, which table below correctly summarizes the benefits of extracting lithium by mining or the reservoir brine method? So benefits means good things, right? So I want to know which one is better in terms of each of these categories, okay? So my first one says the lower, I switch to this side here. I'm going to just check my table. So my first one, actually, I'm going to look for the benefit of each one. So lower emission of CO2 is my first one, right? So if I look at emission of carbon dioxide, it's better to produce less, right? So producing CO2 is not good for our atmosphere and air pollution, so we want to produce less. So in this case, my reservoir brine method is better because it produces less carbon dioxide. Use of water, I want to use less water. Water is a natural resource that humans need to survive, and so we don't want to contaminate that. We want to use as little of it as possible for this process. So in this case, mining has a better benefit. And then use of land. In this case, mining uses less land, so that also has a better benefit there. Okay, so I need to look for which table has the check marks where I just highlighted green. So I need brine reservoir method for lower emissions. That one has it. This one does not. That's not good. This one does not. That's not good. Okay, so I'm left with option 1 and 4. And then I look, I see less use of water in mining. Yep, that's good. That's good. And then less use of land should also be under mining. That is not there. So 1 is not my correct answer. I need option number 4. Okay, lithium production has impacts on land use in the Atacama region of Chile. The photograph shows solar evaporation ponds at a brine extraction and processing facility. The graph below shows some information about lithium. So we can see that we have these solar panels being used to generate heat to evaporate water out of the pools of brine. Okay, and whenever I have a graph, first thing I'm going to do, read the title, lithium production in Chile. I'm going to read my axes. So down here I have year, and on this side I have the production of lithium. So if I look at this graph, I can see that over time I have generally produced more lithium, but there was a slight decrease here just before 2010. Okay, so our question says, which statement correctly identifies the changes to the lithosphere? So lithosphere describes the lands or rocks, the solid part of the earth, that were needed for reservoir brine lithium extraction in Chile between 1995 and 2022. Okay, so we're going to use our graph for this part here. So it says the amount of land that was needed for evaporation ponds increased at a consistent rate from 2005 to 2010. Okay, so 2005 to 2010, we're looking in this general region here, and it says it consistently increased. Okay, so consistent means that you don't see any, you just see a steady, that line should be pretty straight, but it should be going up or down. If it was consistent, in this case increasing, it should be generally going up. It would look like this if it was a consistent increase. It does not look like that, so that one is not going to be true. Okay, number 2 says the amount of land surface needed for evaporations was lowest in 1995. So I'm going to look and say, okay, 1995 right here, that is my lowest, so that's good. And greatest in 2015. So there's 2015. That is not my greatest point. So that is not going to be my correct answer. And number 3 says the amount of land surface needed for evaporation ponds increased between 2015 and 2022. So 2015, 2022, I do see an overall general trend of increasing. So it did not increase at a consistent rate or proportional, but it did increase each year. Okay, so that is going to be my correct answer. All right, my next one's my last question with this. They've given us some information. They told us the Andean flamingo, a bird native to wetlands in the Atacama region of Chile and other locations where lithium deposits occur, is listed as a vulnerable species. The model below shows some information about the reservoir brine method. The graph shows projected changes from 2020 to 2060 in Atacama wetland areas due to lithium mining. Okay. So I can see that. I also have that I have this picture here. It's showing me the process. So we have a wetland where we have brine, which is like salty water. The water from the wetland is filling the saline aquifer. So salty water in the aquifer. Remember, aquifers are where water is stored underground. And they are pumping that water out of the aquifer, pouring it into these pools where it is evaporating and leaving behind these solid salts that they are then using to produce batteries. Okay, and then they gave us a graph. So we have the projected wetland loss, and we have year at the bottom, and this is into the future, right? 2060. So that's why they say projected. And then we have the percentage that's remaining. So they're showing us how much of the original is still there. Okay. And we can see that over time, the amount of wetlands are decreasing significantly. Which statement correctly identifies how the processing and management of saline brine for lithium production in the Atacama region of Chile negatively impacts the Andean flamingo habitat? Okay, number 1 says pumping of brine from solar evaporation ponds adds brine to wetlands. Okay, so pumping of brine. So let's see where that is happening. Pumping of brine. And if we follow this backwards to see where it's coming from, it's pumping brine out of the saline aquifer. Okay, and this says it's pumping brine from the solar evaporation ponds, which are over here. So that is not true. Okay, number 2 says pumping of brine from the saline aquifer. So that's true. We just saw that. It's coming out of the aquifer. Reduces water that would be available for wetlands. So if we look, there's our wetland, and the water in the aquifer is coming from the wetland. Okay, so that is true. We are extracting or taking water out of the brine in the wetland. So number 2 is going to be my correct answer. Okay, now remember, you can't panic if you aren't sure about something when you first read a question. Remember, you have to use the resources given. If you use your resources, you can process of elimination to get to a correct answer.